Okay, so 5.5 alternating series. So we have alternating series. The form is like that, okay? We have a series n equal to 1, 2, positive infinity. We have a negative 1/2 to the n power. Then the first term is when n equal to 1, it's negative 1/2. When n equal to 2, what do you get?
Positive a quarter.
Okay, and when n equal to 3, then we have 8, negative 8, right? 1/8. And when n equal to 4, positive, then negative, right? Can you see that sentence? Change. Sign change that. So this will be negative, positive, negative, positive, negative, positive. So we called alternating series, okay? So sign changing. Negative to positive or vice versa, right? Okay, one more. Then we have this form too. So we have a series from n equal to 1 to positive infinity. We have negative 1 to the n plus 1 over to the n over n denominator, right? So we have when n equal to 1, 1. That's a positive, right? So it's a positive, it's 1, which is 1, right? When n equal to 2, 2 plus 1, which is negative, and then 1/2, right? When n equal to 3, what do you get?
Minus 1/2.
Okay,
Oh,
when also positive, correct? And then when n equal to 4,
minus 1/4.
yeah, minus 1/4, right? And then positive, like that. Can you see that? Change the sign, right? Positive, negative, positive, negative, positive, negative. Okay, so this is the series, which is alternating series. Basically, we change the sign alternatively. Okay, so. Just a leave. Okay. Okay, then look, we have the test. Okay. Test. We should know how to apply, right? So comparison test, limit comparison test a little bit confusing. Okay, this one also a little bit confusing, but you can do it. You're smart, smarter than me. Okay. All right, so theorem. Oh, I have a screenshot. So I have a screenshot, this one. Okay, so let's take a look. Alternating series must be same sign change that, right? So we must check that first, whether sign change or not, okay? So this means sign change. This means sign change that, okay? And then they have n plus 1, n plus 2, so positive, negative, okay? Now, that's the basic format we have to have. But look, in this case, we have a B sub n. They just a name about the series, okay? Now, this B sub n greater than B sub n plus 1. So your one of the homework said that A sub n minus 1. You need to find out, right? There is a 5.2, number 3, like that, okay? All right.
Yep, I did it this morning today. Did it.
Okay, so B sub n plus 1, okay? So nothing special, we're gonna just substitute n plus 1 there. Okay, I'm gonna show you how. Look, we have to satisfy the one thing. They said and then also we must make satisfied this one. We take the limit when n approach to positive infinity, b sub n equal to 0. Then we can say that this is the converges, okay, converges by alternating series test, okay, converges. Okay, alternating series does not tell us diverges, only converges, all right? Divergence test telling us only diverges, right? Not the converges, okay? So alternating series test only tell us converge, but then we have to check the two conditions because there's n part, okay? All right, so let us do this one.
Are you saying that the alternating series test, it can indicate the presence of convergence or not, but it can't tell you whether it's divergent or not? Is that what you mean?
That's correct.
Oh, oh,
Yeah.
okay. That's interesting. There's like a third state in between those two that it could be or something.
Yeah, if two condition does not map here in this case, right? Then we cannot say that, we cannot apply the alternating series test here.
Okay, cool. Thanks.
All right. Okay, so let us do this. Return in whether the series converges or diverges. All right. The first one. The first one we have the series n approach to n equal to 1 to infinity. We have -1 to the n plus 1 over n squared. So if n equal to 1, we get, so basically this form is, we know that it's alternatively change the sign. We know that by the definition, right? Now, we're gonna set it up b sub n. I mean, this is b sub n, and then we're gonna set it up b sub n plus 1, okay? So b sub n plus 1. So we just plug in n plus 1 into the n, okay? So hold on 1 second. Look, b sub n only the number b sub n, right? They don't include, they don't include the negative sign change there, right? Can you see that? B sub n is next to 1, okay? So we're gonna use 1 over, okay? Because we don't include this one. So we're gonna input n plus 1 into the n. So we will have n plus 1 to the second power, okay? So look, n plus 1, n plus 1. Plug into the n, all right? That's how we do. Okay, now we're gonna check that up. So we show that just say this one, okay? And then we're gonna show this. Okay. All right, now take the limit. And now we're gonna show the b sub n equal to 0. Yeah. Take the limit when n approach to positive infinity, 1 over n squared. What do you get? Is it 0 or something else? What do you get?
0.
It's 0. So I told you casual thinking, right? So 1 over huge number, right? So it's close to 0, right? Okay. So yes, then we can say that this is converges by alternating series test. Okay, so let me write down just b sub n. Okay, b sub n because long writing converges by alternating series test. Okay, let me denote it this way: alternating series test. So we say the AST. Okay. You guys okay with this? Okay, let us do this second part. So we have n equal to 1 to infinity, -1 to the n plus 1. And then we have n over n plus 1. Okay. Okay, look. This is a b sub n. Okay, now we're gonna create a b sub n plus 1. So we have n plus 1 over n plus 1. We plug in, substitute n plus 1 into the n plus 1, right? So what do you have? We have n plus 1 over n plus 2. And is this greater than b sub n? I mean, the b sub n is greater than b sub n plus 1. Okay, now limit b sub n, which is n over n plus 1. Okay. Now we have limit n approach to positive infinity, n over n, which is, what do you get?
Just 1.
It's 1. It's not equal to 0, right? So look, they don't satisfy the alternative series test. This one. Okay. so that we can say that we can apply the alternating series test. Alternating series test in this case, okay? Does anyone tell us about this one? Does anyone know about this one? We cannot apply the alternating series test, but we can apply other things. Take the limit. For your reference. So information, for your information, we have limit n approach to positive infinity n over n plus 1 equal to, we have, all right, equal to 1. So it's not equal to 0. So it's diverges. Divergence test. Which is not equal to 0, right? Divergence test. Yeah. Okay. Check it out. All right. So we had that. Okay. We had alternating series tests right now. We have absolute and conditional convergence. Okay, so let's see. Do I have one? This one? Lot of tests. That's why I told you you need to master every day, right? About the test. Since 5.1, 5.1. Okay. Let me just draw, please. Oh my gosh, what's going on? Oh. Interesting. Okay, now I got it. Okay, so I have a screenshot, one more thing. This is the last screenshot. So we have this one. So we have absolute convergence and conditional convergence. Okay, look. We have to understand the word. So alternating series test a little bit easier than comparison test. Okay, limit comparison test, right? Okay, absolute convergence, conditional convergence, a little bit confusing as well. Look. Absolute convergence. We take the absolute value. Converges, then we say the absolute converges, right? But then conditional converges, okay? Look, the original series converges. Original one is converges. But then we take the absolute value, which is diverges. Then we said a conditional convergence. Okay. A little bit harder. Okay, I'm sweating. Oh. It's the same. Convergence is noun. Converges is a verb. Okay, same thing. Convergent is the adjective. All right. Okay. Now we have data 5.15. So that is a definition. We have a theorem. Absolute convergence implies no. Implies convergence. So we have absolute series A sub n converges. Then the series from 1 to the infinity A sub n converges as well. Okay. All right. Let us do example. Determine whether the series converges. Absolutely converges. Conditionally. Or diverges. Okay, so we have the first one. N equal to 1 through the positive infinity. We have negative 1 to the n plus 1 over 3n plus 1. Okay? So whether we want to know about the converge absolutely or conditionally, we're going to take the absolute value. Okay? So if you take the absolute value of the series, oops, it's not 3n plus 1. Okay, if we take the absolute value, then there is no alternating sign, right? So just 1 over 3n plus 1, right? I'm gonna say that. Okay, now, how do we think about this one? Okay, so we're gonna think about, let's say that this is a B sub n, A sub n, okay? Then B sub n, very similar with this one. What do you wanna say? B sub n?
Oh, is this like a harmonic series?
Yeah, very good. Yes. So we're gonna say the B sub n, which is series of n, 1 over n, harmonic.
Yeah.
Okay. Now we're gonna do that. 1 over n. Okay. Try 1 over 3n. 1 over 3n. Let us think later on. Okay, then limit comparison test. So limit comparison test. We take the limit, right? So then we divide A sub n over B sub n. Limit comparison test. Then we have a limit. When n approaches to positive infinity, we have 1 over 3 n plus 1 all over 1 over n. That is, when n approaches to positive infinity, we have 1 over 3n plus 1 times n over 1, right? Okay, then this will be n over 3n plus 1. Then this will be constant term is very tiny, so we can say that. Then we get 1/3. So what's the limit comparison test to say that? So this is the number is not equal to 0, right?
But it's less than 1.
Then we can say that. So here we can say that go to the B sub n. Then harmonic series, right? Converges or diverges?
Converges.
Hold on 1 second, hold on 1 second. We're not doing that. Where are you going? So 1/3. Yeah. So we're doing, this is a little bit confusing. So we're doing limit comparison test, but we're not doing actually limit comparison test. We're doing absolute value, right? So we have to do converge absolutely or converge conditionally, right? Or diverges, okay? Then we can say that in this case, first of all, we know that this is diverges. So we can say that that's not the converge absolutely, right? So hold on 1 second. This is diverges by harmonic series. Okay, now let's see. 3n plus 1. Okay, we have to show that one is converges. So how do we set it up? This is a converges. Okay, oh my gosh. We take the absolute value, right? Then we show that with this one, by limit comparison test, this is a diverges. Now we can say this is a diverges, right? But then look, we have alternating series test we can test out, right? All right, then look. We have let me say that. We have -1 to the n plus 1 over 3n plus 1. So we're gonna show 0 b sub n plus 1. Do we have the equal sign? I don't think so, right? Okay, then we know that this is b sub n in this case by alternating series test, okay? B sub n plus 1, which is, we substitute n plus 1 into the n, so we get 1 over 3 n plus 1 plus 1. Okay, so we get 1 over 3 n plus 3 plus n 1, sorry. Almost done. 3n plus 4. Okay. All right. So this is smaller than b sub n, right? That's true. Okay. Let's show the limit. When n approaches to infinity, b sub n equal to 0. So that is limit n approaches to positive infinity, b sub n, which is 1 over 3 n plus 1. What do you get? You don't get it? Then
Zero.
oh yes, we can say that like this, right? Then 0. Okay. Yes. Then look. One is converges. We take the absolute value that is not converges. So we conclude converges conditionally. Okay. This is a lot of work. Series, let me write down because we said b sub n, a sub n, b sub n plus 1. So it's confusing. So this is series. Please let me copy. One more time, try. Copy. Okay, then I can erase this one. Converge conditionally. Okay. Let me do note since. So for your reference. Since take the absolute value. Averages. Averages. All right, limit comparison test. Then we have and the original series. Converges by what was it? The alternative series test. Okay. I know it's very confusing. Yes, but we understand concept. Okay. And yeah, the first time it's hard to understand, but we need to practice, then we understand better. Okay. Okay, let us do one more. It will be the last one for today. So second part, we have n equal to 1 to the infinity, we have a cosine n over n squared. Okay, so look, take the absolute value, right? So we take the absolute value. We take the absolute value, then what did this one? What can we compare?
Is it a geometric series?
Hmm.
Looks like that.
So look. So whether we need to use absolute convergence or conditional convergence, okay? So we take the absolute value of this one. Maybe you don't remember, let me write down. The cosine, absolute value of a cosine is always sum of or greater or equal to, right? N equal to 1 to the infinity, 1 over n squared. You know why? Because cosine n always between -1 and 1, right? Bounded. Make sense? We have a cosine like this. So does sine x, right? So the absolute value of this, which is equal to 1. Very good. Okay. All right. Then what can you tell about this one? So someone said earlier, what can you tell?
Oh, a geometric series.
Geometric must have the number, rational number.
Oh, no, yeah. Is it a P series?
P series, right? So it's a P
Yeah,
series, right? So converges. P equal to 2 greater than 1, right? Okay, so we can conclude this one also, right? So thus converges by limit test. No, not limit test. Comparison test. This is a B7, right? So this is L7. By comparison test. So quoting the series, the original series. Converges. Absolutely convergence, right? So absolutely convergence. Absolute convergence. Absolute. Tomorrow you will. Absolute. Absolutely converges. All right, thank you for coming. Where is the